when we talk about world, we use words. When we study world, we need numbers. So we have to bridge those two, well, entities. And to do that, we have to measure things. That's a fundamental part of the physics. Everything is based on measuring things. There is a science of measuring. We call it metrology. This is a formal definition of what a measurement is. But in physics, we use a more specific definition. A measurement is this. So first of all, if we want to measure something, let's say we want to measure mass. First thing, we have to introduce a standard of that. How do we do that? We take a thing, we point a finger and say, that's 1 kilogram. That's it. Well, of course, we have to convince everybody else to call this thing 1 kilogram. Well, that's been done years ago. And now we have a standard. Of course, a standard, well, usually we have like 5, 6, no more copies of the actual standard. Yeah. Looks like this. The platinum is, we call it 1 kilogram. If that would be a platinum, I wouldn't be probably working anymore. So the second part is we need a procedure how to compare a property of another object with a standard. And for example, if we want to measure mass, the very first procedure was, well, use the balance. How does it work? Very simple. We need a way to compare the property of two objects. We believe in symmetry. So what I need is something balanced. More or less. We don't really care about big errors. Now, this is my standard. So I know that's what I call 1 kilogram. I also want to flip it so the hooks would be down. What will happen if I let it go? Of course. But if I attach another one practically at exactly the same distance from the pivot, and if they balance, I believe in symmetry, I say, okay, this must have the same property as this one. So I say, this is also 1 kilogram. Well, of course, we need a way to measure different masses. So, is it 1 kilogram? No. All right. What about now? Okay. But they look identical. So each of these probably has the mass a half, yeah, of the total. So if it's 1 kilogram, this is 1 kilogram, which means, this is 1 kilogram. That means this is a half of a kilogram, and this is a half of a kilogram. And that's how we can measure masses. Well, what I have here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Does it work? No. Oh, actually, oops. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now it's 9. It was 8. Now it's 10. All right. This is 1 kilogram, and I have 10 of these. So what is the mass of the single? 1/10 of the kilogram. Of course, now we don't use this. What do we use? this. We can use a third object, a measuring device, a scale, to measure masses. We have it calibrated. What a calibration means? Well, first, we take a standard, and we put it on a scale, and we read it, make a mark. Then we put another one, the same mark, the same mass. 1/10 of the mark, 1/10 of the mass. Twice of the mark, twice of the mass. Very simple. So this is a general idea. We need a standard for everything. In physics, we have several fundamental standards. In mechanics, we have only 3 fundamental standards. This is the first one, the mass. The second is, we'll go back to that, the distance. If we want to measure distance, again, we have to choose a standard. And over the history of physics, there have been many standards. Now, for the standard of length, we use distance traveled by light. But of course, in real life, we just use a ruler or a measuring tape. This is 1 meter. This is 1 yard. So 1 meter, 1 yard, very close to each other. So that's a standard. How do I measure distances? I have to introduce a procedure. A procedure is simple. Place the standard on wherever you measure and count. 1, 2, 3. If this is 1 meter and I have to fit 3 standards, that's going to be 3 meters. Simple. How can I measure smaller things? I can take this and I can divide it in 10 equal parts. That will be 1/10. We call it decimeter. I can divide it in 100 smaller parts. We call it a centimeter. I can divide it in 1,000 smaller parts. We call it millimeter, etc., etc. And we can count how many millimeters and centimeters and decimeters and meters fit in wherever we want to measure. And the third very important standard in mechanics is time. To measure time, we need a process which regularly repeats itself, like this one. One, 2, 3. Get the idea. So we can say, okay, the time which this ball takes to make one whole motion, let's call it a second. That's a definition of a second, and that's how it's been done originally. Again, there are many definitions of seconds. Now we use atomic clock for that, but in real life, of course, we use watches or cell phones. They all have been calibrated to the standard, and of course now we don't need this to measure time.